Here is the first example. I'm going to solve this example by using KVL and KCL. This example is mostly for physics students. If you're a circuit student, the next chapter completely deals with KVL and KCL. We also call them mesh analysis, nodal analysis. So I saw lots of examples in there, but this is a useful example. You're going to look at the circuit in different point of view. If you're a circuit student, please watch the video too. But if you're a physics students, for sure this is helpful. Now here in this circuit we have more than one source. If we have more than one source, definitely we cannot solve the circuit by using either series parallel combination method or star delta, which you don't know star delta, so you cannot solve this by using series parallel combination method. Now the goal, he is asking us to find VAB. Okay, now we know that the current, there are two sources, so I'm assuming this source is supplying a current of I1 and this source is supplying a current of I2. Okay, and I'm assuming this current equal to I. So if I apply KCL at this node, let me say at VA is the voltage at this node with respect to the ground. So as I mentioned, VA is the voltage at node A with respect to the ground. And so here is the node VA, node VB, node B is right there. VB is the voltage at node B with respect to the ground. The goal is we need to find VAB. So VAB is nothing but VA minus VB. Now what I'm going to do, I'm going to apply KCL, Kirchhoff's current law, at VA. So case of Kirchhoff's current law is nothing but currents coming in. So basically I1 and I2, those two currents are coming towards the junction and I is going away from the junction. Okay, so I1 plus I2 equal to I. This is one of the equation. Our goal is finding VAB. How do you find VAB? I can say, if you look in the circuit, the voltage across this 4 ohm resistor, can I say VAB equal to 4 times I. Okay, this is my first equation. Let me label this as first and I'm going to label this as second. Okay, those are the two equations, but I have more than two unknowns. I have I1 is unknown, I2 is unknown, I is an unknown, VAB is an unknown. So I have 4 unknowns but only 2 equations. I need 2 more equations to solve this. Okay, now if you look at this resistor is called variable resistor. Okay, so that's the reason you see the arrow mark. In this in reality, if you have 2 volt battery and 3 volt battery, if you connect them in parallel, it's not a good idea to connect them in parallel unless if it is necessary to get that energy. Sometimes you can practice, but it is not encourageable. If you have a 10 volt battery and a 2 volt battery and try to connect them in parallel, for sure it is not at all encourageable. As to connect these 2 batteries in parallel, this 2 volt and 3 volt, those 2 voltages must be as close as possible. Okay, if both of them are 2 volts, for sure, for 100% with confidence, you can connect them in parallel. If this voltage difference is too high, one is 2 volt, another one is 30 volt, never ever connect those. It will destroy that 2 volt battery. Okay, now so I end up with 2 equations. Now if you look at so if you look at this branch right here, okay, I'm going to separate it. So I have a 2 volt and 0.43 ohm, and I'm saying I1 current is passing through this. I'm saying voltage here is VA, voltage here is VB, and 2 volt. Okay, so if I apply KVL here, so what is the voltage between these two terminals? It must be VAB. So can I say VAB equal to 2 volt minus 0.43 I1? Okay, VAB equal to, I can say, because so the voltage, this is a source, it is supplying 2 volt, but at the same time this is the resistor. For sure there will be some voltage drop across the resistor. Okay, so if you take that voltage drop as 0.43 times I1, so VAB, which is VA minus VB, equal to 2 minus 0.43 I1. This is my third equation. Same way, if you look at the second source, I can write the voltage here. I mean, this is also same node, VB, same node, VA minus VB equal to VA minus VB equal to VAB equal to 3 minus 0.43 I2. Okay, so this is my fourth equation. Now I have 4 unknowns, 4 equations. Let me solve those. So first equation is I have VAB equal to 4I. So what I'm going to do, I'm going to substitute here. I'm going to substitute equation 1. Now substitute equation 1, 3 and 4 in equation 2. Okay, so I will end up with I1 plus I2 equal to VAB. Now can I write this I1 from here? I1 equal to VAB, or 2 minus VAB over 0.43. Okay, and same way I'm going to write from here, I'm going to write I2 equal to 3 minus VAB over 0.43. If I simplify these two equations, if I simplify this, so 2 over 0.43, which is 4.65, minus 1 over 0.43 is 2.32. So 4.65 minus 2.32 VAB, I2 equal to 6.97 minus 2.32 VAB. So I'm going to substitute those two values here. Okay, so I1 basically VAB over 4. Okay, now I'm going to do I1 equal to 4.65 minus 2.32 VAB plus 6.97 minus 2.32 VAB equal to VAB over 4. Now I'm going to bring that 4 to the other side. So if I bring to the other side, so I bring the 4 to the other side, so 4.65 plus 6.97, which is 11.62, minus 2.32, 2.32, which is 4.64 VAB, multiplied by 4. So 4 times 11.62, 46.5, 4 times 4.64, 18.56. Now if I bring 18.56 to the other side, plus 1, which is going to be 19.56, so VAB equal to 46.5 divided by 19.56. The voltage here is 2.377 volt. So the voltage across AB terminals equal to 2.337 volts. Now I can find my I equal to 4 times, I mean VAB over 4. VAB is 2.337 or 377 divided by 4. That will give me current, which is 0.594 ampere. That's the current passing through that 4 ohm resistor. Okay, I'll stop this video here. I will solve more examples in the next video. Thank you.